whenever the function is relative the continuity, you always start from these cases. Okay, look at this another question. Always remember, students, always remember you have to read the statement very carefully. Spend 5 seconds more to read the statement. Your answer will be on the spot. Let's see is the collection of all those set such that the power set such that its power set is countably infinite. Then what will be the set C? How you can solve this question in a 10 second? How you can solve? I get answer quickly is empty. Why? If you remember, if you watch my this lecture on the PY question of the countability, you can get your answer as 10 seconds. How? Remember, student, as I told you, if A is my finite, whatever the set, either A is finite or A is my infinite. There are two options. Fine. Then if A is my finite, then power set is my finite. Fine. If A is my infinite, then the power set is my uncountable. Fine. But always remember, student, the of power set of any set is never countable infinite. Power set is never be a countable infinite, but you can see they are talking about the countably infinite, which is not possible. So that means A must be my 5. So that means empty set is the right answer. If you think about that, what will happen if your A is my, say, countably infinite set, then what will be the power set? The power set is my uncountable. Fine, but it can never be the countably infinite. So the right answer is empty is the right answer. So you can see again you need maximum 10 seconds if you remember, and if you already watch my these previous lectures. You can get all these lectures available at my playlist CSR UGC net, and you can see various lecture related to the group theory, number theory, calculus of variation, all are available at this playlist. I request you kindly like, comment and subscribe on my YouTube channel. I'm very sure once you see I have solved all these question within the 10 second, your reaction will be look like say this once you are in the examination. How? Now, again, a question is related to the bounded sequence. Now, can you get your answer in the 10 second? Again, of course you can. If you are in the computer, if you are in the examination hall, you will look like say this question. But if, believe me student, if you already watch my this previous lecture of the sequence and the sequence of the series, what I told you in these previous lectures, you always start with the sequence of -1 raised power n, or sine of the n, or -1 raised power n over n, and so on. Whenever you remember, your target is always to discard the options. Fine. So now how you can solve this question? Look at that. How you can solve this question in a 10 second. So let's quickly solve this for you. Bounded sequence. Out of this, which one is the bounded? This one is the bounded. This one is the bounded. This one is the bounded. All are my bounded. So you can take any one of them. So let's say I can choose Sn. An is my sine of n. Clearly say which is my bounded. Fine. Does it convergent? Contain a convergent subsequence? Fine. You can get a convergent subsequence. You can also choose as -1 raised to power n. It is a bounded. Yes, it is a bounded. What is the subsequence? 1 1 1 positive and -1 -1 -1. These are my two subsequences corresponding to this sequence. Then he said only one subsequence cancel. Fine, because we get a two subsequence, finitely many subsequence. Now you can prove that whether it's a finitely many or not. You can see this example will work for you. Sin n, what is this? First of all, is a bounded, and Yes, it's bounded because sine of n is less than equal to 1. How many subsequence are there? You can see the limit point of the sine n is -1 to 1. Fine. And you can see this sequence Sn has infinitely many subsequence. Fine. So this sequence has infinitely many subsequence, but he said finitely many subsequence, not always true. We have a subsequence, we have a sequence an whose subsequences are infinitely many. At most two, again, because we have seen there are infinitely many subsequence, at the most two is not possible. The left option D is my right answer of this problem. Always remember student, whenever you are working on the sequence, always consider these counter examples to solve them. You must watch about my these lectures. I have already solved 45 plus question in each video. And you can see the 90 or 100 plus question you will see to remember and to easily take the question in your mind. I am sure that once you have completed this question, the 10 second, again your reaction will be look like this. All this reaction, all those students who have already watched my videos, and once you are in the examination hall, your reaction will be this one. If you are new to my YouTube video, you can scan and join my WhatsApp group as well. Now, what is this question? This is related to the uniform convergence, or you can call it as the pointwise sequence and series of the function. This question is related to the sequence and series of the functions, and again you must watch my these two lectures in order to understand this question quickly. Can you find the limit of this? So what is the limit of this? That is my x square divided by root of x square. What will happen? X square over mod of x. So what will happen? It is my mod of x. So x is a cancel out, mod x is fine, 0 is cancel out. How many seconds you are needed? Hardly a 5 seconds you are needed to solve this problem. And that 5 seconds you are needed to like and comment on this video as well. The number of the solutions of this equation. You can see the given equation is fx is 0. How you can solve this question in the 10 second? Or always remember your target is to find this solution. That means roots finding. Can I write this equation? Or how you can find that? I always use the fixed point equation method. Fine. So what is the fixed point is? I can write e raised to power x is 1 minus x. So draw it graphically. E raised to power x. This is the graph of the e raised to power x. When x is 0, this value is 1. Can I draw the 1 minus x? It's a decreasing function. When x is 0, the value is my 1. So how many points they are intersection? There is only one intersecting point. Fine. So once you know there is only one intersecting point, how many solutions are there? Only one real solution is the answer. Remember students, whatever the question I have explained you in all this here, you must watch about my previous lectures, the tricks or the method which I have explained in my each video, which are explained in this PY question series. Remember, you not only get the correct answer in the less time, but also improve your thought process to attempt the question in the examination. The only thing is, once you are in the examination or once you are watching my videos, you are always watch the video with the positive thinking. Once you are watching the video with the positive thinking, your confidence level will be very high and you are more stronger than the others to attempt the question in the examination. Let me know in the comment box whether your thought process are increased or not after watching my videos. Now, look at this question. This is the one of the easiest question, as I believe that. Can you solve again in the 10 second? What come in your mind when you look about the supremum? Definitely this lecture will come in your mind when you look about the supremum. Your collection of the x. So can you find the value of the x from this case? That is a root 2 plus 1 over root 2 minus 1. And we all know this is the root. Root can never be lies in the denominator. I can rationalize them. 2 minus 1, it is root 2 plus 1 whole square. That means x 2 plus 1 3 plus root 2. So what is the supremum of this? This is my supremum. Fine. So the right answer of this problem is A is my correct answer. Look at that. I have written only the 3 words and you can get your answer in your right manner. Now, look at this question. If you read the statement in your examinations, some of you are look like say very happiness, some of you are look like say very confusing question. Why you are look like the happiness? Because I know you have watched about my uniform continuity and py question of continuity. Fine. Again, this is the question of the continuity. What the shortcut takes, as I told you, you always start with the e raised to power x, or you always start with the constant, or you always start with the linear function. Fine. So let's start with this way. Always read the statement very carefully. Your statement is given to be like a equation number 1. So your all options will be dependent only on the equation number 1. F is a continuous, K is a subset of R. So let's say K is my R. So then it is my continuous satisfying this function. So look at that. That is x minus y is less than equal to this case. What is which condition will satisfied? Definitely one will be satisfied. No. What is it the one satisfied? Yes, one will be satisfied. No. Is the linear function satisfied? Okay. If I look about this case, if I look at the continuous function 1, a simple one, fine, then is this condition satisfied? X minus y is 1 minus 1 0. Is it that itself implies x is equal to y? Fine. But is this condition satisfied? No. Now, okay, this condition is, if you look about the another example, f of x is e raised to power x. Does this condition satisfied? X minus y is less than equal to e raised to power x minus e raised to power y. Yes, this condition will be satisfied. Fine. So you can see that, is it a onto? This is not onto. Fine. So the first option is cancel. Fine. Now look at the second option. F is a onto if k is my 0 comma 1 to 0 comma 1. Again 0 comma 1 is a subset of the R. Now how you can prove that? Again, what is the, now you can see, what can you say about the closed 0 comma 1? Is a compact set. Fine. Clearly say this property implies that f is 1 1. You can easily prove that there is no issue, because if x is equal to y, then, or you can say f of x is fy, this implies x is equal to y, because fx is equal to fy, this is 0, that means x minus y is less than 0, that means x is equal to 1. So f is a compact set, f is my 1 1. So what does it mean? What does it mean? This means f is continuous. Why? That's obvious, because f map from the compact set to the compact set, and f is 1 1, so therefore f is my continuous. Also now you can see what is given to you in the given statement. What come in your mind when you look about this statement? If you remember my this uniform continuity lecture, this will give you f dash is greater than equal to 1. That means f is my monotonically increasing. Fine. Now f is 1 1, f is compact, f is monotonically increasing. So therefore, what can you say about this case? That means f of 0 is less than of the f of x is less than of the f of 1, because f is monotonic. What does it mean? If f is the mapping from 0 comma 1 to 0 comma 1, that means your fx will lies between f of 0 to f1. Fine. By using this condition, Now how you can prove the onto? So your what will be your target? Your target is to prove f of 0 is 0 and f of 1 will be 1. Then only it will be the proper subset of. Fine. So now how you can prove that? That's very simple. I can start with this 1 minus 0. Fine. I can simply say f of 1 minus f of 0. Why? By using this equation number 1, I can choose x is 1, y is 0. Now clearly say this number is a subset of the 0, 1. So definitely this number will be less than 1. So what does it mean? 1 is less than equal to 1 minus 0. Fine. And f is 1, 1. Fine. We have already proved that f is 1, 1. So that means this is possible only if either f1 is 1 or f1 is 0 and f of 0 is 1 and f of 0 is 0, and that is your required target. So therefore this must be the subjective, that's the finals. Look at this third option. F is 1, 1. F is 1, 1. Then f inverse from the k to k exists. That's not true. If f is 1, 1, again I can see fx is my e raised to power x. Fine. Then because this function is my not onto, so therefore f inverse may not exist. Fine. And since the function is my not onto, so this inverse not existent. So this option is cancelled. Look at the last option. F is onto. F is onto given. Also given that f inverse from k to k exists. Fine. So what does it mean? If f inverse exists, that means f is my 1, 1. Fine. F is onto, f is 1, 1. That means f is my bijective. Then your target is to find the f inverse. Again, a very simple. What is given to you? Again, always remember what is given to you. This is given to you. I can use this equation. Another thing is given to you. I can choose as a r to r. Fine. K I can taken as a r. So what is the f inverse? So if I choose the value of the x is f inverse of a, value of the y is f inverse of b. Fine. So then this number will be f inverse of a, this is f inverse of b, which is less than equal to what is the f of x, because f inverse existence and it is 1, 1 and on to, that's a bijective. So this number will be my a minus b. What does it mean? F inverse is satisfied, my ellipse is continuous. Fine. So that means f inverse will be my uniform continuous. If f inverse is my uniform continuous, that means f is my continuous. But he said need not continuous. This option is cancelled. Only right option is B is my correct answer of this problem. So you can see that a very simple approach, but you must watch about my the PY question of continuity and uniform continuity. Okay, if some students will confuse about the second part, I can re-explain you what is given to you. Let me quickly clear the screen now. Fine. Now how you can prove that? Again, I can re-explain you. This is given to you if because your target is to prove this is on. Fine. Now, first of all, this 0, 1 is my compact set. Also, this condition will implies that f is 1, 1. Fine. So now, if f is 1, 1 and it is a compact, so f map compact set to the compact set. Is it fine? Now f is 1, 1. Also, f is my 1, 1. What does it means? F is my continuous. Fine. Also, you can see from this equation number 1, f dash is greater than equal to 1. That means f is my increasing. Fine. So now you can see about this case. if I choose any of the x, it must be belongs to the f of 0, f of 1. Why? Because f map on the compact set to the compact set. Also you can see x lies between 0 and 1. F is 1 1, f is continuous, fine. F is increasing, so if f is increasing, that means f of 0, because it's a closed interval, so equality will also be there. Fx is less than equal to f of 1, that means fx lies in between them. Now how you can prove that this is on is a subjective onto? That means your target is to prove this number is exactly a 0, this number is exactly 1. That is your target, fine, because f of mapping is defined like this. So once it's onto, that means f of 0 will be 0. Now you can see from again equation number 1, I can take an at the end point because I need a 0. X is my 1, so it will be f of 1 minus f of 0, and since these are the subset of 0 comma 1, so definitely the difference will also lies between 0 and 1. So what does it means? 1 is, what does it means? Since the endpoints are same, so you can say f of 1 minus f of 0 is my 1. So what is the possible case? Is a 1 and 0, because it's an increasing function, it's a 1 1 function, so that's why this is my onto. So the right answer is B is my correct option. Okay, look at this another one. Now they are talking about the series. AN is my convergent series. AN, collection of all those AN is my positive. That is called as the subsequence of the AN. Again, this is my subsequence. Then convergent, absolutely, absolutely. I didn't know what is the fourth option because those students who have sent to me, they gave me only the three options. Anyhow, once we will get the complete uh, question paper of this CSIR net, I will explain you again how you can solve this question again in the 10 second. Can you solve that? If you look like say this question is very confusing, but believe me, if you watch about my infinite series playlist or infinite series lecture, you can solve this question in a very less second. How? First of all, think about any of the convergent series. This is my convergent, fine. Then an and bn, what is the an of this? An will be my 1 over n, bn will be minus 1 over n because an is negative. Then an will goes to the 0, correct, but we can't say about this correct option based on the counter example. Clearly say this option is cancelled because this is my divergent by p10, so this option is directly cancelled, fine. An is absolute convergent. Is it absolute convergent? What is the absolute convergent is 1 over n, so this is not absolute convergent, so this our counter example only for the part 2. Now what will happen if you know the series is my convergent? What does it mean? That means limit of the an will be goes to the 0. Now what is your target? Your target is to prove the sequence an will goes to the 0. This is your target. How you can prove that? Now since your target is to prove limit of an will be my 0, so if you take the limit of n approaches infinity, this is already 0, so because an is my part of this convergent series, so since an is my 0, so definitely this option is the correct option. Similarly for the bn limit goes to the 0, so yes, this option is the correct option. Now third option, if summation is absolute convergent, so that means this is my convergent. What does it means? That is a limit of this existence, a 0, fine. This is given to you. Then your target is to prove summation series an is absolute convergent. That means your target is to prove this is also existence. Very simple, fine. So look at that. What is the value of this case? What is the definition of the an? An is my this case. So what is the summation of this? Fine. Now what is given to you? Summation of an is absolute convergent. What does it means? And what is this summation of the is a part of only those terms which are my positive, that is it is the sum of the subset of summation and once this is absolute convergent, that means this is also absolute convergent. Fine, because this is the subset of this absolute convergent series or some subset of the absolute convergent series. This is also convergent, so that means this is also absolute convergent. Similarly, you can prove Bn is also absolute convergent. Okay, look at this another one. Don't forget to like, comment and share this video. You can share this video with your friend as well. How you can prove this question again? Again, this is a sequence. Again, you have to watch this. What is the sequence? I have taken you the counter examples. You can taken about -1 raised power n. You can taken about the sin n. You can taken about -1 raised power n over n. Firstly, you can think about these three cases. See which one is the discount. Let an is a bounded sequence which is not convergent. Which one is a not convergent? You can see this is not convergent. Fine. So I can simply choose the an is -1 raised power n, which is my bounded. Fine. And it is not convergent because the limit is not finite. Fine. This satisfied. L, the subsequence of the an which converges to the L. So clearly say you have the two subsequence, 1 1 and second is odd series -1 -1 -1. So clearly say this is my convergent, this is my convergent. It convergent to the my minus of 1, this convergent to the plus 1. So S is empty, wrong option. S contain exactly one element, that's again the wrong option. Same the two examples. If I choose this counter example, fine. So you will get L is either 1 or -1. Exactly one element, that's a fine. Cancel. At least two element, that's fine, is a finite. Now once is that they are talking about the finite, we can choose the another example, sin n. Fine. So clearly say it is a bounded. Fine. So therefore definitely there exists a subsequence of this sin n. Definitely there exists subsequence which is obviously dense in the limit points. How many limit points are there? -1 to 1. These are the limit points of, and how many limit points are there? Which is infinitely many limit points. But he said finite. So what is the L? L is any number which lies between -1 to 1 and it is my infinitely many. So that's a cancel. Only left option is C is my right answer. Always remember student, you must watch about my previous PY question series. I have already explained all these questions with this simple three counter examples. Again, this is the bounded sequence. I think you are look like a very happiness in the examination hall. Why? Look at that. It's an infimum, supremum. Again, you can watch about this lecture. So what will happen if limit infimum and limit supremum are same? What does it mean? That means the sequence is convergent, fine, and bounded. So yes, this is my true statement, but we need a false statement. Okay. Moreover, they are talking about, before I can start this, let me give you the some tips for you. We all know what is the relation between the limit infimum, supremum, infimum, and all that. Infimum of the an is less than or equal to the limit of infimum of an is less than or equal to the limit of supremum of an is less than equal to supremum of an. Fine. Now let's see limit of infimum, that this limit and this limits are same. That definitely if the limit infimum and supremum are same, what does it means? That means limit of an existence, and once the limit of the an is existent, that means the sequence an is convergent. So yes, this option is correct, but we need a false statement. This is cancelled. Look at the second option. If supremum of an, this option, and limit of the infimum both are same. Once they both are same, let's say both are equal to 1, assume that, fine. So if this value is my 1, this value is my 1, that means limit of the supremum is also 1, fine. So what does it means? That means limit infimum and limit supremum both are equal. Once they are equal, that means the limit of an existence. Once the limit is existence, that means an is convergent. So that's a correct option. But again, we need a false state. So what do you mean? That means the first and the second options are same, but their representations are different. Infimum of an and limit of supremum are same. Once they are same, again you can see limit of the infimum and limit of the supremum are same. So that means an is my convergent, but they are look about the constant. It is not true. Why? Because you can see if I choose this simple sequence, is it bounded? Yes. Or you can simply choose 1 over n. Is a bounded sequence? Yes. Limit infimum and the limit supremum are same, which is a 0, but this is not constant. Is it a constant? No. So that's the correct option. Supremum and infimum are same. That is the endpoints are same. Once the endpoint limits are same, that means the infimum and sup are also same. So that means all are my same. What does it mean? That means if all the limits are same, that means if the minimum is 1, maximum is also 1. That means the sequence is my constant sequence. Yes, this option is correct, but we need a false state. Fine, because the limit infimum, limit supremum, limit infimum, sup all are same. That means the limit, the function is my constant. Okay, now if you look about this question again in the examination, and if you tired after watching this question in the examination, again you miss to watch my videos. What come in your mind when you look about the injective, isomorphic? If you remember, you have to watch my py question of the functions and the py question of the continuity. What shortcut takes, as I told you, first of all, if f is a mapping from a to b, fine. We all know if the cardinality of a is less than of the cardinality of b, then we can say f is 1 1, fine. On the other hand, if cardinality of a, sorry, if cardinality of a is not less than of the cardinality of b, then f is not 1 1. Cardinality of b is not greater than of this, that implies f is not on 2. Fine. Now you can see about that. How you can solve this question? First of all, is a r. What is the cardinality of the r? It's uncountable. Fine. Cardinality of qx, this is my countable. Fine. Now look at the first option. There exists a 1 1 map from r to qx. What is the cardinality of this c? Is it a less than of alpha naught? It is not less than, so that means f is not 1 1. So yes, which of the following is true? This is not a true, because he said it's a 1 1. Fine. There exists a 1 1 map, that's a converse. So that means yes, it's satisfied. So this will be happen. Isomorphic, you can talk about the bijective. When it will be the bijective? Whenever the cardinality of a is equal to the cardinality of b, then you can say this is my bijective map. But you can see they are not same. So that means this option is also cancelled. There does not exist any map from R to QX. Remember, they are not talking about the 1 1 or on 2. They are not talking about 1 1 and on 2. They are simply talk about the mapping. Very simple. Very simple. How you can think about that? Assume that. Assume that there exists any map from QXR to the QX. What does it implies? That means f of r is the subset of this. If it is not onto, fine. But we can assume that f of r is a subset of the QX. Now, what is the dimension of the r? It is 1. What is the dimension of the QX? What is the dimension of the QX? This is my infinite dimension. So what does it mean? What does it mean? That means f map every, because there exists a non-zero. So f map every non-zero real number to the sum non-zero polynomial. Fine. F map non-zero real number, f map non-zero real number to the non-zero polynomial. So but you can see qx. What is the dimension of this qx? This is my infinitely dimension. Fine. So what does it mean? But f is my one dimensional, so this is never be the subset of q of x, because it's a infinitely many dimensional, and this is, so therefore there does not exist any map. Yes, this option is the correct option of this problem. So that means in this case, the only the concept of the dimension will be applicable. However, in the first three options, they are talking about the 1, 1 on 2. So you are talking about this coordinate. Okay. Which of the following is a linear transformation is a 1, 1 and on 2? What is the first option? Uh, you can get the answer in the 5 seconds in the examinations. Again, you have to watch about the PY question of continuity. What does the meaning of the first question? That means it's a bijective. So once is a bijective, what is the cardinality of the r raised to power m? This is m. Cardinality of the r raised to power n is n. So for the bijective, whenever there is a map from the A to B, when it will be the mapping bijective, when the cardinality of A is equal to B, but he said m is less than n. Fine. Now t is on 2. When is a t is on 2 but not 1 1? If that means if t is not 1 1, that means m is not less than of the n. Fine. That's the meaning of this. And because it is not 1 1, it means it is not bijective. If it is not bijective, that means m is not equal to n. So the only case which is left behind is m is greater than of the n. And that is also satisfied for the on 2. Yes, this is satisfied. T is bijective implies m and n are same. T is 1 1 implies wrong, because this case is only for the bijective. For the 1 1, we must need as the m is less than of the n. So right answers are B and C are the correct answers. If some of the options are different from the options mentioned by the students, then you can change these options and you can look about this concept. F is the cardinality of the A and cardinality of B. Okay, look at this another one. If you think about this again it's a sequence. How you can start with this sequence? You can start with the -1 raised to power n, sine of n, -1 raised to power n over n. But if you look about that, these are my positive sequence. That means this is not possible, this is not possible. Sine n is also negative. So I can start with this n. Fine. So look at that. If an is n, which of the following statement is my true? Okay, if an is n, if an is n, so what is my bn? An is my n, maximum of a1 1, a2 2, a3 n and f. So what is the maximum of this? Because n is a positive sequence, so the maximum is my n. So therefore bn will be my 1. Fine. As n approaches infinity. So first option, so that means we are talking about these two options. Fine. Bn existence, limit is existence, fine. Then the limit of the an is also existence. What is the an? Does it existence? It goes to the infinity. So the second option is cancelled. An is a bounded. Is it a bounded? So these two options are cancelled. Fine. Now look at the first option. Bn is 0. First of all, what is the Bn? An divided by maximum of AIs. So clearly say, because it's a positive sequence, this number is greater than 0. And maximum of AIs, definitely it is less than of the 1. So therefore, Bn will lies between 0 and 1. So 0 satisfied, half satisfied. Now, what does that the meaning of the Bn will converges to the 0? That means An over maximum of this will converges to the 0. Fine. Then your target is to check whether An will goes to the 0. Now, if you look about this condition, what does it means? That means An is very smaller to the 0 if this condition happens, because this is given to you. So what does it means? An is approximately with the 0. It's a very small number. Fine. Now your target is to prove An will goes to the 0. Let's assume that An is not goes to the 0. What does it mean? There exists some epsilon, fine, so that An will be greater than of the epsilon. Once it will be greater than of the epsilon, that means the maximum of A1 up to An will also be greater than of the epsilon. So that means if epsilon will be any number, so whenever you can take an n is greater than of the m. So if I choose n to be the very large number, fine, what will happen of the bn is does not goes to the 0, but it is given to be that bn goes to the 0. So therefore an not convergent to the 0 is not true. So once this is not true, that means this condition will be satisfied. Fine. Now you can see again bn goes to the 0. What does it mean? Another way you can say bn minus 0 is less than epsilon. Fine. Your target is to prove an goes to the 0. Assume that it is not goes to the 0. That means your an will be greater than epsilon. Because an is a positive sequence, I can simply assume an is greater than epsilon. That means maximum of ai's will also be greater than epsilon. The what is the meaning of that? Bn is also greater than epsilon. That is a contradiction of this portion. So therefore, this is not possible. The only case is an will be 0. Now, look at this. Bn will convergent to the half. What does it mean? Bn minus half is less than epsilon. Fine. So I can choose any of the epsilon. Say epsilon is half. Then again I can say this number will be less than of the 0. Fine. Because it's epsilon is half. If it is my half, if I open this, it is my 0. So by the again the first part, that means the limit of the an existence. So yes, this is existence. So the right answers are A and D are my correct answers of this problem. So you can see that it's a very simple way you can find the limits of this sequence. I hope you can like and subscribe my YouTube channel as well. You must watch about my this two lectures in order to understand this lectures easily. So you can see that all these lecture you can find about the real analysis in this PY question playlist. You must watch and learn how you can tackle the questions and how you can attempt the question in a less time. Please don't forget to like and comment on the video. I hope you can share this video with your friends and you can subscribe my YouTube channel for the more videos. Best of luck students. Happy luck.